What's up, guys? It's Kevin from Others on the Map, and today I am covering our entire electrical system, which I'll review everything in this electrical compartment area, as well as our DC fuse blocks, which are right above you in our upper cabinet here. But before we get started, I do want to say one thing. I am not a certified electrician, and this is for entertainment purposes only. This is my first time putting everything together, and I just wanted to show you what my electrical system looks like. But please do your own research, please contact professionals, and make sure you're doing everything right. So in terms of everything that we have three 100 amp hour batteries. We have one 3000 watt multi-plus Victron inverter. We have a Renogy Rover 40 amp solar charge controller. That's an MPPT charger. We have a Murray 60 amp AC circuit breaker panel. And we have two circuit breakers. One is a tandem, two 20 amp circuits on a single pole, and then we have a 15 amp breaker on a single pole as well. In terms of our setup, we have a battery monitor and a shunt, and we also have a multi-plus Victron inverter controller, so we don't have to open up this shelf every time we want to turn the AC power on. So for our DC setup, we have two Blue Seas fuse block panels up in this upper cabinet that is connected to our bus bars in the electrical component. So we have 300 amp hours of batteries, right, of lithium batteries, but we need a way to create energy, create power. Batteries are there to store power, we need a way to create it. So we have three ways to create power. One is through the shore outlet, which I showed you how we installed it in a previous episode. And that's great for when you're connected to an RV park or someone's house or whatever. I can plug it into a regular extension cord to an AC outlet from my house. The second one is through our solar panels on the roof. We have four 100 watt panels on the roof on a custom DIY solar roof rack made out of 80/20 aluminum. There's a video below showing you how we put that together and wired everything up, so you might want to check that out. And then our last one is through our vehicle's alternator via a lithium BIM isolator, and we have that wired up. I'm going to be creating a future episode to show you how that's set up. So in total we have three sources of energy, so hopefully we'll never run out of power. Alright, so I'm filming this with the doors closed, so I'm not allowing any wind in because it'll be pretty loud. It's pretty windy out today, so if I start sweating, that's why. And if you hear some humming, I have the fans on. I don't have the max air fan because I think it'll be a little bit too loud, but I'm going to do my best and make sure that this is the best quality for you. So we'll start at the batteries, and I'll show you where everything is wired to, and then we'll go from there. Here's the top view of our electrical compartment. So I wanted to make it pretty spacious because, one, you're supposed to have a good amount of room between, like the inverter, for example. You're supposed to have like 10 centimeters on both sides, and it's pretty difficult to do that in a van unless you have like a platform bed and it's underneath. So for our setup, I wanted to keep plenty of ventilation through and plenty of room, as well as an opportunity for me to upgrade my system if I want to add another 100 amp hour battery, which I can place right here, or maybe squeeze it through that area between the AC breaker and the inverter. But I think right here would probably be the best spot. But looking at our setup, we have the 3 amp hour batteries secured down by I think this is pipe tape. I'm pretty sure, and this isn't going anywhere. We have it going both ways, horizontally and vertically, and we also screwed down some wood strips on all sides to keep it in place as well. So these batteries really aren't going anywhere, and they're going to be pretty secured. So when I was trying to figure out what wires to use, I was searching blogs and other websites, and I stumbled across Nate from Explorers Life, who has great resources on electrical components. And in fact, this bus bar design is actually from Explorers Life. So check that out. I'll drop a link in the description below. I'm also going to be creating a blog post and wiring diagrams and the entire electrical system diagram on our website, mathersonthemap.com. So it's not going to be up immediately when this video is out, but stay tuned, come back to it, and you can use it as a reference in the future. But now it's time to dig in and get into what we have here. All right, so in terms of our wires for our batteries, we're using 2/0 wire, and I actually just bought a spool of this size wire and then cut it down and made my own short cables using some heat shrink and crimps. It's a lot easier to do this instead of, you know, buying 5-6 inch wires with crimps on both sides. I highly recommend getting a spool and doing it yourself, because then you can custom fit it, because it's going to be really tough to plan exactly how your layout's going to be before you get everything put together. So the real brains of the operation is coming from our batteries to the bus bars, both the positive and the negative. So for our positive, we have a 300 amp terminal fuse right here connected to a 2/0 wire that goes to our master kill switch. So on the left side of the switch, we have the battery wire coming into it, and this is a copper bar, and I'll put in a couple clips describing how we built the bus bars. And if you don't want to watch this, just jump to the next clip. All right, so this is what we got. This is the lead going to the kill switch. Go right here, and then we'll connect our solar charger controller to this, as well as our battery bank. And then this one is our positive bus bar, which connects to the other side of the master kill switch. And then, like I said in the previous clip, we have 4 holes here. One is going to go for our isolator, that's going to be connected to our alternator to charge our batteries when the engine's running. The next one's going to go to our inverter. And we have 2 holes for our 2 DC fuse blocks. Then over here, this is going to be our negative bus bar. It's going to attach to the battery shunt, and then we'll have 6 negative wires attaching 1 on each side of this here. So here's the finished product of the copper bar put together, creating my bus bar. So I switched over to the GoPro to get a little bit closer, but this is the battery line, and then we have a 40 amp A&L fuse that's connected to our solar charge controller here. So this is coming directly from the charge controller, this wire here. And then this little guy is connected to our battery shunt, which is what powers the battery monitor. So from the kill switch, we go into our positive bus bar, and we have 4 connections. The first 2 here are for our DC bus bars, and that's 6 gauge wire down below, and I believe these are 100 amp fuses each, because our DC fuse panel is 100 amps each. So we have 2 of these for both panels, or both fuse blocks. And then our next one here, this is actually our fuse for our isolator. So this is a 250 amp A&L fuse that's connected to 2/0 wire that's running all the way through this little setup, through the back of the kitchen cabinet, and along all the way there to the isolator to the front battery. And lastly, here we have our 300 amp A&L fuse that goes to our inverter. I just realized the isolator here should be underneath the A&L fuse, so I'll have to redo that. So now let's take a look at the negative bus bar. So here again, we have 2/0 wire coming from our batteries over to the DC, or the negative bus bar, and this is where the battery shunt lives. So I have this running to the battery side of the shunt, and then I have the bus bar on the opposite side of the shunt. Now this bolt is a little bit thicker, so I had to drill a little bit bigger for both of these, which you could just do manually with a drill. And then these are regular 5/16. So again, here I have 6 connections to the negative bus bar, 1 on each side. I have in the back here, in the back I have 2 that are running to our 2 fuse blocks. In the front here I have this one that leads directly to this charger controller right here. And then I have this one that goes directly to the inverter. So Victron actually recommends using 2 2-aught cables for each terminal connection on the both positive and negative lead. That's why you see more than 1 bolt on each terminal connection. However, I only have 1 cable ran for each. I'm going to monitor this over time. From my initial tests, everything worked pretty good. I could even power a hairdryer, but this is a good example of where you may want to consult a professional and ask a certified electrician. And then I have my 2 negatives, or my 2 grounds. So one is grounding the inverter right there, and then this one is actually grounding the entire electrical system to the chassis. From an inverter setup, I have 10 3-wire, which is Romex. I wish I didn't use Romex. I wish I used stranded wire when I first did this, but you live and you learn. On a future build, I'll have this as stranded, connected, but this connects to the AC in for the inverter, so this connects to our shore power outlet. And then we have 6 3-wire coming from the inverter into our AC distribution circuit breaker panel. So I have my 6 3-wire coming through here, and it's connected to the negative, or the hot line, or the hot connector. And then I have the neutral connected to the neutral bus bar on top. And then I have a jumper cable, or whatever you call it, that's 6 gauge wire coming from this side, connecting it to this hot terminal connection. I don't really know the correct terms. Again, I'm not a professional, so please connect with a professional when you're doing your setup. And then here's where I have my 2 20-amp circuit breakers on a single pole, and then I have a 15-amp on a single pole as well. In terms of the wires coming from my solar panels, these are these 2 right here, and they run all the way across my setup, down below, and then into the charge controller. So let's show you this. So you can see here, this is a pretty tight space. So before installing this to the wall, I just wanted to make sure I know which one is which. So we have the solar positive, the solar negative, the battery positive, the battery negative. When you're setting this up, you want to connect your batteries cables first before the solar panels. This is in the instruction manual for the Rover charge controller. You make sure you want to do that. So connect your battery cables before your solar. So for the AC, we have, like I said, 3 breakers, the 2 20 amps and the 15. This is a 60 amp circuit breaker, so it can handle up to 60 amps, and we have 55 here. For the 15 amp, we have our outlets that'll be running our lower accessories, our lower amperage accessories, like a vacuum charger, not the actual vacuum, just the charger. We'll charge our laptops and other small AC appliances. So it connects to this outlet right here, which is where we'll house our vacuum in this storage area. And then it continues through into the hole into the wall, and we have an outlet here. This is 15 amps. And then this one goes all the way through and over to our electrical drawer here. So here's another 15 amp. Now for our 20 amp, we have 2 20 amps. One is a dedicated line to our hot water heater, which goes through again and goes up through the ceiling and right over to here onto this timer switch. and that's connected to our hot water heater in the electrical compartment below, or in the water compartment below. Here's Taylor.
Oh, I'm so fairly yawning.
She's yawning. I'm boring, I guess. I'm sweating, but we have it on a timer switch because the water heater sucks up so much energy that we do not want to forget that it's on. So it's only on for like 20 minutes or so, and then it'll kick off, and we will make sure that we don't kill all of our power. Our second 20 amp fuse goes to 2 AC outlets, again running through the same hole here, and that connects to this 20 amp outlet and this 20 amp outlet here. And that is for our larger appliances like a hairdryer for Taylor and a blender if we want to make smoothies or something like that. So we can run it, or we can use it. We tested it out. It's pretty sweet. Now, from a DC perspective, like I said, we have two 12 fuse panels, both Blue Seas. So it's a little messy and a little difficult to manage, but we're not going to consume all 24 fuse blocks or fuse spaces. And I maybe could have put them on one fuse, but I was just a little nervous. This is my first time doing it, so I wanted everything to have its own dedicated circuit with its own fuse. So we have a lot of different components, and I'll try and run through them all, but they range from different fuse sizes, and I'll document what what my setup is and what fuses I have working here. Alright, so in terms of our setup here, I'll quickly walk through. So we have a line for our kitchen electric ball valve that goes to our gray water tank. The next one, I called it a poop fan here. I labeled it as a poop fan, but it's for our toilet, our Nature Heads toilet fan. And we have our shower light, our shower electric ball valve for that gray water tank. And we have our water pump below here. And then on the right hand side, we have our 12 volt drawer. So we have our USB and 12 volt socket or outlet here. Then we come in above this is our water meter. So water meter right here. This is our 3-gang switch, and by 3-gang switch I mean the USB right here, as well as another 12 volt outlet. And here's our ball valves. So ball valve, and water pump. And then on the right fuse panel we have our driver side USB, which would be coming out of that wire right there. So that'll be a bedtime USB port. Same with the passenger. So this is passenger USB. We have the toilet light, or no, this is the toe kick light. So we're going to be putting an LED strip so we can have some, I don't know what you would call it, soothing lights at night, and we're not waking up each other when we need to go to the bathroom or just, you know, be up a little later. We have the front lights, we have the back lights here, we have the line to the fridge, the busbar diesel heater, and this is another one for the diesel heater. So lots of setup, and we're still not done. We have to add a line for the WeBoost, but we're pretty much 98% there. But also this is going to be where we're storing our monitor section, so we'll have like a wall here, and we got that idea from Sarah and Alex, which we really like, so we're going to copy that setup. But here's our Victron battery monitor. You can see that it's 100% right now, and we have, it's plenty of sunshine, so our solar panels are keeping us in good shape here. We also have our water monitor, so we have a 1/4 tank of water right now. And we also have our Digi multi controller for the inverter. So I could click this on. It's now on. The inverter's on. See that blue light or green light right there. And then if we wanted to, we could charge something via the outlets. And you could see that I have this plugged in to the AC outlet here, and it's charged. Now the cool thing about this setup is that we have a master control switch here, so we can turn off everything if we want to do some work on this setup without having to disconnect the batteries and such. So I'm just going to turn off the inverter real quick. So you heard the click, the inverter turned off, and now I'm going to turn off the master switch. So I have the lights on right now, and I'm just going to turn it off. And the lights are now off, the fan's now off, and it's getting even hotter now. But this is a great little setup, and I highly recommend doing this because then you can just flip the switch and then you can work on your system without worrying about getting electrocuted. So definitely consider that when you are doing your install. I'm going to turn this back on. Our lights are back on. The fan's back on. And if I wanted to, I can cool down. Much better. You might be wondering that this might be a little dangerous having this exposed with the copper bar. So I did cut the A&L fuse holders, the plastic protector piece, so I can put this over the copper bar like so, and this would clip in just like that, and I can do that for all four here, so I'm better protected. So I hope this video was helpful. Again, this is our entire electrical system. We have enough battery storage and a large enough inverter to power pretty intense appliances like a hairdryer, a blender, a hot water heater, and then we have plenty of ways to create energy. Like I said in the beginning of this video, one through solar panels, another through the battery's alternator via the isolator, and then shore power if we truly ever need it. But if we're driving, I really don't think we will, even if it's pretty cloudy. So unless we're just stopped for a while and it's cloudy, no sunshine, then we'll have to plug in. Other than that, if you want me to go into more details on a particular component of the electrical system, please let me know in a comment below or shoot us a message. I try and answer pretty much everything that comes our way. And if you want to stay tuned for a future episode on how I wired up the isolator to the battery's alternator, then consider subscribing because that should be coming up in the next 2 or 3 videos. So thanks so much for watching. We really, really appreciate it, and we'll see you next time.